Hey there, Mike here. I am really hungry, but breakfast doesn't open for another 25 minutes, so I thought I'd go over divergence of a vector field and how to find that. If you're looking for a divergence theory, that's going to be another video I'm probably going to put up later today. So yeah, let's just jump right into it. So for this, all you really need to know how to do, you need to know what it is, first of all. Divergence of vector field F is going to be del dot vector F. And you need to know what del is. And you need to know how to take partial derivatives. All these things are really easy. So first, let's go over what is del. It's a crappy computer company, but more importantly, it's like this upside, this kind of delta sign here with a vector over it. It equals the vector. Assume we're doing three variables here, three directions, nothing crazy four-dimensional. You're gonna get d over dx, d dy, and d dz. Looks really bad, but yeah. So that's what del equals. So literally all you're going to do to find the divergence of f is dot that with vector f, and dot product is pretty easy. So I gave us a vector f up here. I made it as ugly as possible just to show how nice divergence theorem usually makes things for you, especially because it gives you a scalar quantity, and that's just a lot of win there, a lot of win. All right, so here we go. Let's set this up. So let's take our directional thingies first, whatever. So for I hat, we got 7x plus y squared, and we're going to be deriving that with respect to x. For j hat, we got here 3e to the zx squared, hope none of you ever have to see that again, minus 9y. And we're going to be deriving that with respect to y. And for k hat, forgot what came after j for a second there, you get 7x e to the y minus the natural log of e to the y. Yeah, so that's about as ugly as it can get, and we're going to derive that with respect to z. Alright, and from here on it's pretty simple. You're just going to find the partials. So let's get on that. It's going to equal 7. There's no x in there, so we treat that as a constant. Derivative of a constant, of course, is 0. 7 plus 0. Over here for j hat, we got, looks like there's no y's on this side, so we can ignore that. It's going to be 0. It's going to be minus 9. Y derives out to 1. And then down here for dz, looks like we can completely ignore everything. There's no z involved at all. The whole function is treated as a constant, and again, the derivative of a constant is always 0. So we got 7 minus 9 minus 0. So divergence of f in this case is going to equal -2. And yeah, that's about it. I don't know what else to tell you. It's pretty easy stuff. For the definition of divergence, which you may have to know, it's basically how outgoing something is, like the outgoingness of something. It's a weird concept. It's like say you got like something like this, and you got like a point in here, and like the goingness is like this way, and you want to know how much it's outgoing in that direction. That's what you find. It's a weird concept to wrap your mind around, but it's good to know, because later on, when you have to use the divergence theorem, it's going to be a big lifesaver. So definitely make sure you know this. And I'm going to grab breakfast now, so take care. Mike out.